So let's get back to vector addition. As we studied before, vectors traveling in one dimension are pretty easy to deal with. Imagine we've got a bucket, a pail, that's being pulled up with some tension T. The weight of the bucket is some force W. Well, to figure out the net forces acting on the bucket, we subtract W from T. So the sum of the forces equals T minus W. So let's imagine that T is 30 newtons and W is 20 newtons. That would be 20 newtons. The sum of the forces would be T minus W, or 30 newtons minus 20 newtons equals 10 newtons. Now we also have to have a direction. So we would say that this is 10 newtons up, or maybe north. We can also look at the case where, get back to our pillow fight. We've got a force going this way of 12 newtons and a force going this way of 11 newtons. The net force and the direction the pillow is going to be the sum of the forces equals the forces going to the right minus the forces going to the left. So that would be 12 newtons minus 11 newtons would equal 1 newton east, because the net force is going this way, because this one is bigger than that one. So that's forces in one dimension, but we want to move to forces that are in two dimensions. So let's say we have two vectors. One that goes 4 in east, and one that's going 3 north. So we'll call this one, what we do is we follow the rules just like we did before. We take the tail of the second vector and put it on the head of the first, so that we get something that looks like this. It's going to be 4 east and it's going to be 3 north. And so I know they're at a right angle to one another. So if this is 4 and this is 3, we've got something that's got the making of a triangle. So the first rule is take the tail of the first vector, put it on the head of the second, and then we draw a line from the tail of the first vector to the head of the second vector. And we call this the resultant vector. So we call this one 4, and we'll call it vector A. And we'll call this vector B. Well, to figure out the length of this side of the triangle, we can do that if we know the length of this side and this side. You may be familiar with the Pythagorean theorem, and it would go something like this. R squared is going to equal A squared plus B squared. So therefore, R will equal the square root of A squared plus B squared. And what we can do is we substitute in the numbers for the letters. So A squared equals, let's say, 4 meters squared plus 3 meters squared. Take the square root of that. and that will equal r. So it would be the square root of 16 meters squared plus 9 meters squared, which equals 25 meters squared, which equals 5 meters. So r is going to be 5 meters. But we're not quite done yet. What we need to do is we need to figure out the direction of r. So we want to figure out what angle it makes with the horizontal. We call this angle theta. So that's a circle with a line across it. It's a theta. Well, the angle theta is calculated using the tangent function. This angle depends on the relationship between the length of this side and the length of that side. And the relationship of these sides is what we call the tangent. So angle theta, and follow this formula for now, we'll elaborate more on it later, but angle theta equals the inverse tangent, so that's tangent with a -1 there, of the one that's in the y direction divided by the one that's in the x direction. Now, you calculate the inverse tangent using your calculator. There is a button on there. Usually it's above the one labeled tangent. It's usually written in yellow. So it'll be find the tan -1 button on your calculator, because that's what you're going to use. So I'll set it up this way. The inverse tangent of y over x, so since 3 is in the y direction, 3 is on top, and 4 is in the x direction, that'll be on the bottom. So then we go to our calculator, and let's figure out the ratio first, right? We should know that's 0.75. So we type in second inverse tangent, 0.75, and enter, and you should get 36.9 degrees. If you don't get 36.9 degrees, you may have your calculator set in radians, so make sure you change your calculator from radians to degrees. If you have a DEG button on there, you can push it and it will change. So, the resultant vector is 5 meters at 36.9 degrees north of east. So this one's running east-west. East direction is going to be this way, and so it's going to be 36.9 degrees north, pushed to the north. So that's all there is to it in dealing with vectors at 90 degrees to one another.